This is the core concept, one of the key concepts of calculus. So one is limits, other is derivatives, and the third is integrals. Let's say you're driving in a straight line. So this is your position x, and this is 0, and you are here somewhere. And I plot it with time. So the distance, I'm plotting x here and t here. Or I could call this y. So y is how far I have moved at time t. And let's say I plot this with time and I get something like this, okay? And this is where I reached wherever I was going. Suppose I'm going from home to school. What would this indicate? And here I reached wherever I was going. So this would be the distance of the school from my home because I reached here. Because on the y-axis, I'm plotting how far I have traveled, and t is the time. So if I am trying to figure out my speed, this is one dimension. I'm saying speed or velocity, right? What is velocity? Suppose I'm looking at, let's say, from here to here, then these are the points. The change in position is this. Let me call it delta y. Delta y is the change in position from this time t1 to time t2. And this is the time interval or time that has elapsed. I can call it, say, delta t, which is t2 minus t1. And if this is y1 and that is y2, then y2 minus y1 is the delta y. So velocity for this interval is delta y over delta t. But this is the average velocity. Okay, it's the average over the interval total. This is the displacement and elapsed time. Now, when you're driving, you look at the dashboard and you see a certain, it's showing, particularly if it is digital, right? It is showing a particular speed that you have, or even on the dial, right? If it says you're going at 30 kilometers per hour, what is the interval we are looking at? That's not average, right? That is at that moment. It keeps changing. So if you want to say what is the velocity at that moment, that's the concept of instantaneous at that moment. There is no elapsed time, instantaneous. So that's the concept we're trying to define. And this is related to moving in a straight line. Now, if I want to find what's my velocity here, right? If I try to do delta y over delta t, then my delta t is 0, right? So then it's not going to work. Let's take some interval to begin. This is my interval, and if I connect these, then I can figure out the average velocity, which is delta y over delta t. And now what I'm going to do is I will shrink this interval because I want to find out at that moment, right? So what I'm going to do is I'll start bringing the right endpoint closer. So if I bring it here, it will become that. And if I bring it further, even closer, then my interval is shrinking towards 0. And if we can figure out something for 0 interval, then my average velocity would have become instantaneous velocity. So what is this thing called? This is called a secant. So a secant line crosses a curve at two spots near some. That's a secant. So here we are talking about close to this. It's crossing in 2 points, but if you go further, it may cross again. So as I shrink this interval, eventually it will become this line. And what is this line? This is the tangent at this point. This was delta y and this was delta t, right? So what is the slope of this line? So the slope is same as this, right? Average velocity. So the slope of the secant was delta y over delta t, and which is also the average velocity. But if we shrink this delta t to 0, then it becomes tangent. If delta t goes to 0, then secant goes to tangent and average velocity goes to instantaneous velocity. So we can define the instantaneous velocity as limit delta y over delta t, where delta t goes to 0. As we shrunk the interval, the secant became the tangent, the interval shrunk to 0, and the average velocity is now the instantaneous velocity because it's at that moment. Now I'm talking in general where I'm saying this is y, this is x, right? I gave that idea, and now we are kind of trying to define what a derivative is. So this is C, so y equals f of x, f of c, and let's say this is any x near c, some x, and this will be f of x. I find the slope of the secant. What is the rise here? And what is the run here? F of x minus f of c, x minus c, right? So what is average rate of change? And if I need to make it instantaneous rate of change, then I need to bring x to c, correct? X and c should become 1. Then this interval goes away and I am at c at that moment. So what I have to do is I have to do limit x goes to c, fx minus fc, x minus c. This is called the derivative of f of x at x equals c. So derivative and instantaneous rate of change are the same thing. Average rate of change is different. This is the definition of the derivative. It's also called the first, even though we're not saying it. If we don't say it, it is implied. It's the first derivative. And we'll see why, because you can have second, third, fourth, like that. Okay, there's one other way this can be written. When we did this, right? We said this was C and this was X. And I say, okay, this interval is H, which could be positive or negative. If it's negative, X is on this side. Then I can write as X equals H plus C or C plus H. And then if I plug that in there, limit f of X is C plus H, right? F of C plus H minus f of c over x minus c, c plus h minus c is just h. Now there is no x here. So writing limit x goes somewhere does not make sense. I have h instead. So if x goes to c, what does h go to? As x get closer to c, h get closer to 0. So h goes to 0. This is another way to write f prime c. This is the first derivative of f of x at x equals c. So there are two ways to write this definition. They mean the same thing, like we just did a change of variable. So in general, this is written as f prime x, first derivative of f of x anywhere at any x. This is at a particular value c, right? Or also written as d over dx, f of x. This means d over dx means differentiate with respect to x. So later we will see if your expression has different variables, then you have to say with respect to which variable are you finding the derivative. Okay, and if f of x, if that is y, you can also write it like that. They all mean the same thing. Sometimes you might see it written like this also.